So this problem says solve tan x minus 3 tan x is equal to 0 for x being between 0 degrees and 720 degrees. Give your answer to one decimal place. So there's really two different ways, or well, there's lots of different ways we could solve this, but I'm going to go through two different ways to solve this. The first way that we could solve this is by using a calculator. So the calculator that I have is a TI 84 plus. So if your calculator is different than that, it's going to be a slightly, or it could be a slightly different strategy. But most of the graphing calculators, the TI graphing calculators are going to be a similar method. If you would like to see a solution using a different calculator, then leave that calculator down in the comments and I will see what I can do at making you a video on specifically that calculator if it's different. And the second strategy that I'm going to use is more of an algebraic strategy. So if you'd like to see the calculator strategy, I'm going to do that one first. And if not, you can take a look at the algebraic, and I'll leave a link down in the comments as to what time that you should start looking for the algebraic strategy. Okay, so with that done, let me start with the calculator strategy. So the first thing we want to do is what's on the left-hand side, we can plug that into y1. So if you hit the y equals button on your calculator and then plug in your tan x minus 3 sine x into y1. Because the other side is 0, we don't have to put a y2. If we had something on the other side that was not 0, we could put that into y2 and then find the intersection points. But since it's 0, we can just use the zeros function on our calculator. So I first plugged that into y1, and then I hit graph. I noticed that my window was way out of whack. I couldn't really see what was going on. So I went and I pressed window. And since my x values, I'm wanting to go from 0 to 720, I like to give myself a little extra room. So I did my x min. I put my x min as negative 10 to give myself a little bit of room, like left of 0. And I put my x max at 730. So again, I'm giving myself like 10 degrees to the left and 10 degrees to the right of my x values. And from there, I did my x scale as 5, but not sure that that's really that important. I put my y min, since usually with trig functions, you're mostly going between like -1 and 1, but because there was a tan, I wanted to give myself a little bit more space, so I went ahead and made it -5 for my y min, and my y max I put as +5. That you could just kind of start as a guess, and then if you can't see very well, then you might want to change that to something a little different, but that was what I guessed originally. And I put my y scale as 1, but not sure that that's really that relevant in this problem. Okay, and then once I set my window, I hit graph again, and it shows me a graph that looks something like, I'll try to draw it, but I'm a pretty bad artist. So it looks something like, goes like that, and then like that, and then like that, and then, whoops, hey, wrong thing, there we go, and then like that. Okay, so every time the graph crosses 0, these are all going to be solutions. So my solutions are going to be about here, 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 and here. So that already tells me that I have like 1, 2, 3, 4, 5, 6, 7, 8, 9 different solutions. So we want to make sure we get all 9 of those solutions using the graphical method, or at least it should be 9. This one here on the end might be a little too far to the right. We can check to see on that. Okay, so what I do from here is I hit second calc, and I choose the option of the 0, which is option number 2. So once I do that, it gives me a cursor and it's asking for the left bound. So I want to like scroll all the way to the left so that my cursor is in the negative region for x. So I know that I'm to the left of 0. So I make, as long as my x is negative, I'll hit enter, and then I'll move for the right bound. Once you hit enter, it asks for a right bound. So then you want to scroll to the right to make sure your right bound is, to make sure that you can see that your that your cursor is like to the other side of 0. So I made it so that x is equal to 13 point something, and I hit enter. And then you put a guess. You want to make sure that your cursor is as close to the 0 line as you can. So I hit enter, and I get one solution as being x is equal to 0 and y is equal to 0. So when it's asking for our answers, it's really only looking for x. So we can put that one of our answers is x is equal to 0. And these are all in degrees. We can continue doing that same strategy using the second calc and find all of our solutions using that method. So we would hit second calc again and then hit 0 again, and then it'll ask for our next left bound. So we want to make sure that our cursor is to the left. So I'm putting my cursor approximately here for the left bound, and then I hit enter, and then I move my cursor to the right of this next point, which would be approximately here, and then I'll hit enter. Then I'll give it a guess, and I try to get it as close to the orange dot as I can, and it gives me that my second solution is 70.5 degrees rounded to 1 decimal place. So that would be my second solution. And again, you can go through all of these solutions and find them using the calculator, rounding them to 1 decimal place. And you're only looking for the x values when you're doing that. You're not worried about the y value. So that's the strategy if you want to use your calculator. If you're not allowed to use your calculator, or if you would just like to learn an algebraic method, we'll go over that now. So let me clear this out. Okay, so using an algebraic method. The first thing I would do using an algebraic method is to write my tan as sine over cosine. So we have sine x over cos x minus 3 sine x is equal to 0. Now I want to get this cos x out of the denominator. So I can multiply everything by cos x, and that gives me sine x minus 3 sine x cos x is equal to 0. From here, I want to factor out my sine, because I want to factor this so I don't get rid of any of my solutions. So that leaves me with sine x times 1 minus 3 cos x is equal to 0. Now that I have it in a factored form, I can set each of my factors equal to 0 independently. So I'll write it as sine x is equal to 0 and 1 minus 3 cos x is equal to 0. This one's already solved for 0, but let me solve my cos x, or let me solve for cos x. I'll subtract 1 on both sides to make negative 3 cos x is equal to negative 1, and then divide both sides by negative 3 to make cos x is equal to 1 over 3. So from here, what I want to do at this point is to think about this as like on the unit circle. Where is sine x equal to 0? Sine is equal to 0 when we are at y is equal to 0. So that would happen at x is equal to 0 degrees, because this point is when x is 1 and y is 0. And since sine is the y coordinate, this would mean that sine of 0 would equal to 0. And again, we want to find where else sine would be equal to 0. The y values go up to positives going up here, but then we go back to 0 here at 180 degrees. So at 180 degrees would give us another value of sine being equal to 0. Here, if we continue around the unit circle just to see if there's any more solutions, the y's go into negatives, and then it doesn't hit 0 again until we get back to this point. So it would hit again at 360, which we could go ahead and put, but I'm actually going to, if we only think about it from 0 up to 360 but not equaling to 360, once we find those two solutions on the unit circle, then to find any more solutions up to 720 degrees, we can just add 360, because if we go all the way back around the unit circle, we would hit this solution again. So if we add 360 to 0, we would get 360, and that would be another solution. And same thing for the 180. If we go all the way around the circle again, then once we hit back to 180, which is then 180 plus 360, that would be another solution. And 180 plus 360 is 540. So that would be another solution at 540 degrees. And then once we come back around here to 720, we are wanting 720 to be part of our solution. So yeah, we need to make sure that we've cleared all of our solutions. So 360, if we add 360 to that again, we get to 720. So these solutions are all the ones from sine. And if we think about, well, I said I wouldn't, you don't necessarily have to watch the calculator version, but the calculator version showed that we had 9 total solutions. So this gives us 1, 2, 3, 4, 5 of our 9 solutions. Okay, so next for cos of x is equal to 1/3, where cos is positive, but between 0 and 1 is in quadrant 1. Once we get to quadrant 2, cos is negative because that's where the x values are negative. Same thing with quadrant 3, the x values are negative there as well. So, but once we get to quadrant 4, the x values are positive. So we're going to get our 2 solutions on the unit circle in quadrant 1 and in quadrant 4. So because this is not something, 1/3 is not a fraction that we can find on the unit circle, we'll need to use our calculator and do x is equal to the cos inverse of 1/3. And if I plug that into my calculator, I get rounded to 1 decimal place, I get that to be 70.5 degrees. So that means that this angle right here is 70.5 degrees. And if that is my angle here in quadrant 1, that's going to be my reference angle in quadrant 4. So if this angle right here is 70.5 degrees, then we are 360 degrees around the circle less 70.5. So we can find that value as 360 minus 70.5, which I get to be 289.5 as a second solution. Now that we've found the 2 solutions on the unit circle, like between 0 and 360 degrees, we can add 360 degrees to go all the way around the circle for each of our answers to find the rest of our answers in this region. So if we add 360 to 70.5, we get 430.5. So that would be another solution. And also our 289.5 solution, if we go all the way around the circle again, we would get to another solution as well. So 289.5, we need to add 360 to that, and we get 649.5 degrees. And if we continue further than 649, like if we added 360 again, then we would be higher than 720. So this gives us our remaining 4 solutions that we were looking for. Okay, so there you go. I hope this video was helpful. If you have any questions, feel free to leave those in the comments, or um, or if you have a problem that you would like to see, another homework problem that you would like to see, feel free to leave those in the comments as well. I try to do as many of these videos for free as possible, but I also do paid tutoring. If you'd be interested in paid tutoring, um, my email is down in the comments in the description below. If you'd like to contact me on that, I do a free trial of my a free 30-minute trial of tutoring if you'd like to get that started, and I can do that online. I usually use Zoom. And by the way, I also have had quite a few people asking me about how I write on the board, and I left a link to an Amazon link down in the description for the way that I use my, I have a digital pen that I write on, which allows me to write on the screen. So if you're interested in doing any online tutoring, or if you are being tutored, it can be helpful to have one of these digital pens to make it easier to write on the board. So I do recommend getting one of those if you are interested in doing much online tutoring. It's also helpful for a lot of other things, but yeah, very helpful for online tutoring. So anyway, thanks for watching.